So this is question 2 from 2024 May-June, Physics 9702. So 2a tells us to define velocity. Now velocity, as we know from the formula, is displacement divided by time, which means the definition of velocity is going to be change in displacement over the change in time, or we can simply say divided by time. So velocity is change in displacement over time. So 2b, a student throws a ball over a vertical wall of height h, as shown in figure 2.1. Okay, so they're throwing the ball at a height of 1.2 meters and a distance of 36 meters. This is a projectile motion question, and they're giving us the magnitude of the velocity as well, and the angle it makes with the horizontal. The ball leaves the hand of the student at a height of 1.2 meters above the horizontal ground. The ball has an initial velocity of 22 meters per second. At an angle of 40 degrees, the ball is a horizontal 36 meters. Air resistance is negligible. This means there is going to be no acceleration on the x-axis, no horizontal deceleration. Okay, so we're just going to use uniform velocity to find the time taken. So we have S equals 36 meters, which is given. We know the acceleration is 0. A is going to be 0. And we know that the velocity, or the horizontal velocity, x velocity, is going to equal to 22 meters per second times the cosine of 40 degrees. Because if we look over here, we basically have a triangle, a right-angled triangle, and this over here is the opposite. This is going to be the vertical, and this is going to be the horizontal. Now the horizontal is adjacent and the vertical is opposite, and this is the hypotenuse. So we have adjacent over hypotenuse, so we have to use cosine. So we know velocity, and we know displacement, and we know acceleration, and we want to find time. So we can use one of our kinematic equations, S equals ut plus a half at squared. Now we know that a equals 0, so this will completely cancel out, and we're just left with S equals ut. We can rearrange for t, so t is going to equal to S over u. T is going to equal to 36 meters divided by 22 meters per second times the cosine of 40 degrees, which is going to give us 2.1 seconds. Because we're rounding from 2.136 seconds. Okay, but we're rounding to two significant figures because our ounces all have to be to two significant figures. So we know the time now. Calculate the vertical component u of the initial velocity of the ball. So we know that u is going to equal to 22 meters per second times the sine, because this was times the cosine, this is going to be the sine because this is the vertical, since it's opposite over hypotenuse, so sine of 40 degrees. And this should be giving us 14 meters per second. Now we could check with Pythagoras, and if we do that, we should get 22 meters per second. The ball just goes over the wall. Calculate the height h of the wall. So we know the time. Time is equal to 2.1 seconds. It takes 2.1 seconds to reach the wall. We know that the initial velocity is going to be 14 from the previous step. And we know that the acceleration is going to equal to negative 9.81 meters per second squared because it's gravity. And it's a negative because gravity is going to be acting downwards on the ball. It's going to accelerate it downwards. And we want to find displacement. So we want to find how much the ball goes up by. It could go down, but on the diagram it says it goes up. Okay, so we should be expecting a positive displacement here. So S is going to equal to the same equation over here. S is equal to ut plus a half at squared. And we just substitute in 14 meters per second times 2.1 seconds plus a half times negative 9.81 meters per second squared. And then we have to be very careful and put some brackets around here. 2.1 seconds squared. We have to make sure that we square this. Alright, and we should be expecting 7.8 meters as our final answer for the displacement. Now, the total height is 1.2 plus the displacement. So if this is the displacement, we need 1.2 meters plus the displacement. So h is going to equal to 1.2 meters plus 7.8 meters. And this is going to equal to 9.0 meters. And we have to keep the 9.0 because it's two significant figures. And that's how you solve question 2. Thank you for watching, and please subscribe if you found this video helpful.